Good afternoon, everyone. Thank you once again for joining us here on Facebook Live. We're so glad that you could join us once again this afternoon. We are excited to continue our work in this virtual world. And today we're going to be sharing with you some of the things that you can look for in the evening skies throughout the month of February. So when you get your coat and your hat and your gloves and everything all together with your family, you can go out and explore those cool February evenings. I'd actually like to begin this afternoon by acknowledging the Dakota people, the indigenous keepers of the land in which the Bell Museum sits. This land was reserved by the Dakota in the Treaty of Traverse des Sioux, signed within the United States in 1851, and the land remains sacred to them today. I would also like to acknowledge the Ojibwe people and the other indigenous inhabitants of this land. Dakota and Ojibwe knowledge systems are crucial ways of knowing this place now called Minnesota, and we at the Bell Museum honor that knowledge and the values embedded within it. We do have some individuals on site at the Bell Museum today. We're hoping that with some clear skies, we can share some telescope views with you. But for the time being, I'd like to turn things over to planetarium educator Thaddeus to get us started.
All right, excellent. Well, hello, welcome everyone. I can't see, but I hope you're all seeing me coming through this somewhat sunny afternoon here, a little chilly out. And I'd like to follow up with Amber on what Amber was just saying there, to acknowledge the Ojibwe and Dakota people, the original inhabitants of this land. Today I'll be talking about the sky, and although I'll be focusing on the Western constellations, along with events happening in February, there's a great wealth of knowledge related to the sky inherent in Ojibwe and Dakota and every indigenous culture across North America. So although I won't be, I don't have the authority to share that particular information, I would encourage you to look up this information out there. One of my personal favorite sites is Native Sky Watchers from Dr. Annette Lee. Dr. Lee has worked for years to bring this knowledge out to the community. And as part of her Native Sky Watchers program, she does that in a really beautiful way. All right, again, I'm going to be sharing mostly Western constellations and also events happening in the sky. So we're going to start off here by jumping to our sky here at the beginning of February. Now, our February sky, as far as great giant celestial events going on, our February sky is kind of quiet. There are a few things, though, that are occurring throughout the month and throughout the night, actually. So we are starting here in the evening. You can see the view of stellarium here, hopefully, is popping up. We've got our date and time is up in the corner here, and I'll keep that up so you always know when we're looking. And down in the lower left, hopefully the text is a little small there, but we're looking at from Minneapolis, from the night sky from the Twin Cities. But if you're really anywhere in here in Minnesota, the sky, what you're seeing here today, will be very similar to for wherever you are. All right, now the first thing here, just to acclimate ourselves to the sky, we are looking to the south. Orient ourselves. So we've got southeast on my left here, and southwest is on my right. That might be flipped on your screen, but we've got south right in front of us. And one thing we can see all throughout the month of February, and that I'm sure you've all been seeing yourself if you've been looking out at the night sky, is you can see Orion. Orion here is pretty much right in front of us to the south here at about 10 o'clock. Most distinctively, very easily found by his three belt stars, three bright stars right in a row. Basically can't miss them. Even with a lot of light pollution like we do have here in the Twin Cities, Orion's belt still stands out. You can also see the star above it, the reddish-orange star Betelgeuse. Over the other shoulder is Bellatrix, the female warrior, and Rigel and Saiph. And with these stars and a few more, his bow here, we find the hunter in the sky. And in fact, this has been recognized as a hunter or a person in almost every culture that's looked at the sky and made up these star patterns. We have records, in fact, suggesting that this was the great hero Gilgamesh in ancient Babylonia. One of the first great heroes we have recordings of. The Greeks and Romans saw him as Orion the Hunter. Now, Orion is really great. He's fantastic constellation, or what you're going to call him. Fantastic constellation to find because he really helps guide us around the sky. So in fact, just in this general area of where Orion is, we can find like half a dozen more constellations. In fact, if you start his belt right here, the 3 belt stars, Alnitak, let me make sure I get my names right, Alnaheim, and Mintaka. These 3 stars, if you follow them, just go downwards. If we follow them downwards about a hand length in the sky, we can find the bright star Sirius, or the dog star. Sirius, the brightest star in our nighttime sky, the heart of Canis Major. And this is just one of Orion's hunting dogs. In fact, Orion has another hunting dog, a very small one. If you head upwards from Sirius, and sort of an angle from the belts or over from the shoulder of Orion, however you'd like to do it, bright star sort of by itself is Procyon. Now, I've already given away what this is. It does take a lot of imagination. This line that you're seeing in the sky is Canis Minor, or the smaller dog, the smaller hunting dog of Orion. It is also in Greek constellation lore, it is one of the most absurd constellations we have. I prefer to think of it as the stick that Orion threw for Canis Major, the leather dog. Going back to Orion and his belt, though, he is hunting things, of course, as a hunter. His belt points us upwards to this bright reddish orange star called Aldebaran. Aldebaran here is the eye of this giant constellation, Taurus, or the bow. Taurus, the bull here, fighting against Orion, and depending on what mythology you're reading. In fact, Taurus here is not being hunted by Orion, but Taurus is actually Zeus, the god Zeus, turned into a bull, and he's protecting the 7 daughters of Atlas. We can see those 7 daughters. In fact, in this drawing here, Taurus is pointing right to them. We can see these 7 daughters, which you might also know or better know as the Pleiades, or the 7 sisters, or M45, Messier 45, if you know your Messier deep sky objects. Now, just like Orion in these constellations, the Pleiades will be up throughout February. They are a beautiful sight. They're very distinctive in the sky. You might not see 7 stars. Here with light pollution in the cities, I might see like 4, maybe 5. If you get away from the cities, you can pick out a lot more. And if you grab binoculars, it is a great way to view this deep sky object. They'll show some of the hundreds of stars that make up this entire cluster. So the brightest stars we see are just some of the stars that are all joined together. And they're very young stars. They're actually only about 65 million years old. So this is what we call an open cluster of stars. Very young stars that have been born fairly recently and are moving around the galaxy together. For a short little while, that is. Eventually, these stars will go their own ways. They'll spread outwards and they'll go out and they may become single stars like our sun, just all on their own. Or we might get some binaries or maybe even trinary star systems out there. But all starting, in this case, appearing to start from that point. It starts a little bit earlier, but we'll come back to that later. Just continuing Orion here, his belt pointed us up to Aldebaran or down to Sirius. You can also, if you start at Rigel on the foot of Orion and you travel up through the center of the belt, up through the star Aldebaran, you can imagine this line extending onwards and outwards until you come to 2 stars pretty close by, about a hand length away from each other, hand width away from each other in the sky. These 2 stars are Castor and Pollux. And Castor and Pollux here are the twins. Or you might also know them as Gemini. So the twins are up here. Again, very easy to find, like the rest of these stars, actually. And finally, let's come to one final constellation just in this area of the sky. And actually, to be honest, Orion is a great way to star hop around the sky. This constellation is sort of a little bit more separated. There's not a super easy way to find it beyond just sort of looking for it. And what's great this time of year is that to look for it, you just really need to look up. Because right near to the top of the sky in the early evening, we have the bright star Capella. Capella right here is one of the brightest stars in the sky. Forget the exact ranking of it. But but it is so bright and so easy to find. And it marks out this sort of roundish, oblong sort of shape there. To me, this is just the giant blob in the sky. The Greeks and Romans did see it as Auriga, the charioteer. Earlier, I said that Canis Minor, the smaller dog, is one of the most absurd constellations. To me, this is right up there. All right. Luckily, those Greeks and Romans are not around to hear me make fun of their constellations. That's good. These six, if we include a very small one there, these 6 constellations here have been visible throughout the winter, and they'll be visible throughout February and into the late spring. And you can connect together the bright stars, Capella and Castor and Pollux and Procyon and Sirius and Rigel and Aldebaran. You can connect these together into a great circle in the sky, sometimes called the winter circle. And if you want to learn more about how to find them, you can check out our Constellation Hunter video series. They're linked on our Facebook page, but they're a series of videos that my colleague Sarah Komprud has made detailing how to find these constellations in the night sky. All right. Now, I've said this all this time so far, just here at one part in the sky, just one part of the early evening. And truth be told, you could spend your entire year just looking at one part, or entire month just looking at one part of the sky. But we will move along. We'll see some other things here. In fact, we'll go just a little bit later into we'll go to about the middle of the month, excuse me. So I got my date and time up there on the right, and I'm gonna step forward. We can see even as we go forward into the evening, or excuse me, into February, into the month, at the same time at 10 o'clock, these constellations are still visible. But as we go forward in the month, some new things do come around. Looking over to the south, the west-southwest, kind of close to the horizon here, we have something new that's come along, a very bright light. You might have seen it pop into view there. Right over here, we have our moon, which will be nearby the constellation of Taurus. Now, you probably don't need much help finding the moon there. It is very bright and very easy to see. On the night of February 18th, though, it is going to be very cool to look for something right nearby the moon. Just looking a little more closely now, you can hopefully spot that reddish orange spot nearby the moon. It's only going to be a few degrees away from the moon. This evening, we will have a conjunction of the moon and of Mars. Now, I'm sure one or two of you probably heard about a little conjunction that happened at the end of December 2020. Kind of made the news, just a little bit. That conjunction of Saturn and Jupiter. That conjunction was very rare, only happening every few decades, and where Saturn and Jupiter got incredibly close together. But conjunctions on the whole, where two objects pass by close to each other, those can be pretty common, especially when it comes to our moon. Our moon, moving around the Earth in just about 30 days, passes by hundreds of objects, hundreds of bright objects, thousands if you can count all the really faint ones. And it often passes by planets. So a conjunction of the moon and Mars is a somewhat more common event, but still kind of a pretty cool thing to see. And it also does make Mars a little bit easier to find if you're having any difficulty with it. Truth be told, you might not have any difficulty with it. Mars is a very bright point of light in the sky. It has that very distinctive color. It doesn't twinkle like the stars do, so it really stands out there. Now, it's still well positioned to see in the sky. We're looking here now to the west in the early-ish evening. And if you have binoculars, you might see a tiny bit more detail. Mars, though, as a very small planet, does generally require the use of a telescope to make out any real amount of detail. At only about a third the size of the Earth, you need something that can collect a lot of light, say a 8 or 10-inch telescope, and you need a lot of dedication. Just personally speaking here, it takes sometimes a good 20 minutes or more, maybe upwards of an hour or several hours, or over the course of several nights, to really start to pick out any faint detail on Mars. We are looking here. We've got a great view of it, though, and with our imagery from NASA and spacecraft. We've got a great view of Valles Marineris, the Mariner Valley cutting across the surface of Mars here. Now, I said that Mars is about a third the size of the Earth. The Mariner Valley is about the size of the United States. So that's about 2,500 miles across, if that gives you some sense of the scale of Mars. If it doesn't give you a sense of the scale, that's totally okay. The United States is huge. I mean, so thousands of miles across. That is a huge distance. Just as large, we have the Tharsis volcanoes, or excuse me, not just as large, but also large, we have the Tharsis volcanoes. And a little bit further along, we also have Olympus Mons. So the circular area right here, like these circular ones here, are not craters, but these are volcanoes rising out of the surface. And in fact, Olympus Mons right over here, this volcano, that one little area on Mars, that's just a little bit larger than the state of Minnesota. So, small planet, but it's got some really big features on it. All right, coming back to our larger view of the sky here, I will turn the labels on, in fact, for Moon and Mars, now that we've found them there. Oh, and we can also see, if you do a bit of telescope, I'll quickly point out, we do have Uranus here down below the Moon and Mars, again, looking to the west. You will need a telescope to see Uranus. I mean, binoculars will show it as a bright point of light, but it's not super distinctive. In my experience, at least, I've needed to use a telescope at least 4 inches across to really be able to pick it out. But it does have a nice pale blue color there in the sky, a nice round pale blue dot. Slightly different from the pale blue dot we're standing on right now. This is one of our ice giants. So far out in the solar system that elements like oxygen are frozen in the atmosphere of this giant planet. And it is giant, not tiny like Mars, but instead about 4 or 6 times the diameter of the Earth. With its own very faint little ring system here, you can see as well. All of our giant planets have rings, although the ones around the ice giants were only discovered very recently with flybys of the Voyager spacecraft or observations by the Hubble telescope. We also see the moons of Uranus here, which I will not guarantee you will ever see unless you have maybe the Hubble telescope. Some of you might recognize some of these names as well. The moons of Uranus are, with some exceptions, named after the characters from Shakespeare, from the plays of Shakespeare. A couple of exceptions, though, are moons that were found early on and were named after Alexander Pope, another English poet. And I want to pause. I know Amber knows this for sure. I'm always so good at talking. I'll come back to our southern sky here, or actually orient ourselves right to this direction. But Amber, have we had any questions so far?
I haven't seen any direct questions, just a lot of thank yous, and also an individual that has that shares an issue that I share, in that their neighborhood is very bright and their neighbors have very bright yard lights. So if you have any advice on how to deal with that, I think that would be much appreciated.
I wish I had better advice. I have the same issue. Some bright lights, but also some bright street lights, just the street lamps. The one that every time I walk outside, I see it and I think, oh, there's the moon. And then I remember it's that street light that's super bright, which is super disappointing. One thing I would recommend, especially in my case, I haven't had a chance to, it's on my list of very long to-do list, is actually to talk to the city of St. Paul and see if they have a lighting plan. This is something that's been growing in popularity among cities. Lighting plans or lighting ordinances are ways to minimize the amount of light that spreads out uselessly, basically. A light shining in my window is not very helpful, by the way, St. Paul. So lighting ordinances usually dictate not maybe the brightness of bulbs, but especially the type of lamp, the type of shade that is on top of the bulb. So for example, the street lamp itself. There are shades that are made that help direct the light down, or they cut off light from shining upwards. So you still get all the light down on the ground where you want it, but you minimize that light shining upwards. Now, these are actually shades that are available. They're called cutoff shades, sometimes I believe the name is. These are ones that are available for consumers as well, everyday folk. And for that, I recommend checking out the International Dark Sky Association. Amber might be able to throw a link in the chat there about that. IDSA, International Dark Sky Association. They have links on their website to shades like that help cut off some light. Of course, in this case, as the question was, or the comment was, it's your neighbor that's got those lights. The best thing I can offer is, if you're in a position to do so, to just hop over and talk to them. See if it's something they've sort of realized. I know personally, I had a light on my back porch that was on a motion sensor, and I until one night, I didn't even realize how often it just went off. It was super sensitive. It was going off. There were bugs flying by, and it just went off. And I eventually just turned it off entirely. It wasn't really doing a lot for me, even with that motion sensor there. My next step is to, now that I know it's a problem, is to look into these cutoff shades that the IDA recommends. So again, if you're in the position to do so, maybe this is just something your neighbor hasn't thought about, and they can turn those lights off. They can help turn them off later at night. And they'd be willing to purchase a shade or try to upgrade to a motion sensor. Motion sensors, I think, are a great way. They're a great compromise between wanting that light there, needing it, for example, when you're coming home in the dark, you're working late, which I do a lot, needing that light, but not interfering with everyone else's enjoyment of the night sky. All right. Very long answer there, Amber, which I suppose gave a chance. I'll just check in one more time before I move on. Any other questions or comments, things I might be able to talk about?
Nothing yet. I think everyone's just excited to see to hear more about what we can see in February. Okay, well, let me definitely get into that then. And let me talk about one of those things. One of the great things about having dark skies, and one of the reasons we promote things like cut off shades, talking to your neighbors, turning off your lights, is that there's so much more to see up there under dark skies. In fact, this view that I'm seeing in Stellarium that's coming through your computer, this view of the night sky is one that I do not get from inside the city. In particular, this band of the Milky Way going across the sky, this hazy, cloudy thing up here, cutting in between the constellations of Orion and I believe just Orion up there, Orion and Taurus, and the twin, or there's Canis Minor and the twins up here, Capella right along the path of it. The Milky Way is basically impossible to see from inside the city, although easy to track down with these constellations. Another thing that can be hard to find, but helps to find constellations for, are some of these deep sky objects. Now, I'm going to spin around, we can see the asteroid Vesta marked out there. I'm going to spin around to our northeast. That's going to be pretty good, because if we look to the northeast here, middle of the month at 10 o'clock, standing straight up and down in the sky, some of you have been really waiting for this, we have the Big Dipper. One of our favorite star groupings in the entire sky. The Big Dipper is so recognizable, I think, along with Orion's Belt. Probably, it's the first one I learned how to find, so I think it's the first one a lot of people learn how to find from talking to folks. The Big Dipper is part of this larger constellation, get it up here, of Ursa Major, or the Larger Bear. So we can see the handle of the Big Dipper and the bucket of the Big Dipper make up the tail and the end of the bear. And of course, many of you also know, if you learn to find the Big Dipper, you also learned how to use the bucket of the Big Dipper to point the end of the bucket that points over about 2 hand lengths to the North Star Polaris, or the end of the Little Dipper, or the Little Bear. And, as I've been clicking on these stars, you may notice there's a lot more information that's popping up in the corner there. We can see a lot more names for Polaris. There's a lot of information there. If you're interested in learning more about this, I highly recommend checking out this program that I'm using called Stellarium. It's a great way to explore the night sky and to explore these different cultures as well that have looked at the night sky. Now, with these 2 constellations, we can find so many more objects, but especially when we get into those dark skies, away from light pollution, if we convinced everyone in the Twin Cities to turn off their street lights, we would be able to find some really great deep sky objects right in this area of the sky. Now I've turned them on. I'm actually gonna have to make sure they're popping up here in the program as well. There we go. A few more popping up there. Get a few names up. In particular, right around Ursa Major, we have a host of different galaxies we can see.
In particular, we've got a lot of other things as well, but in particular, I'm going to come near above the sort of the head of Ursa Major. So I always imagine if I'm looking for this object in the night sky, I look for the eye of the bear, sort of right around here, and then I come upwards about a hand width or so. And right over here in this part of the sky, a hand width above Ursa Major, we can find two galaxies, M81 and M82, also known as Bode's Galaxy and the Cigar Galaxy. These are two of my favorite galaxies to look at in the entire night sky. Although, to be fair, I have a very long list of favorite galaxies, but they're definitely right up there. Bode's Galaxy in particular, I've had some amazing times looking at. Both of these galaxies, though, are pretty easy to see, relatively speaking. They are tens of millions of light years away from us, around, I want to make sure I get this right. I'm going to say around 50 million light years away each. Someone please double check me on that. Make sure I got that right. Excuse me. And the information's actually up in the corner. See, I should read what's there. 11 million light years away, plus or minus. So that was kind of close. Each of these, though, about 10 million light years away. They're very easy to see because they're actually galaxies that are associated together. They're what we call interacting galaxies. From what we can tell over the last few billion years, these two galaxies actually brushed past each other. And as they brushed past each other, the mass of all the stars and the gas and dust in these galaxies stirred them up and caused new stars to form. So this is, in fact, like looking at millions of groups of stars like the Pleiades, fairly new young stars giving off a lot of light, making these galaxies really easy to see. In the case of Bode's Galaxy, we're looking almost face on, and so we can see these spiral arms here wrapping around the central core. So just from the look of it, M81 here is actually very similar to our Milky Way galaxy with its spiral arms. And again, that bright core, and we can see some dark dust lanes. If you're looking with a telescope, you will not see all this detail. Just so we're clear, this is another image from, I'm going to guess and say, the Hubble Space Telescope, which has done some of the premier work of all the telescopes we have. Nearby, the M82 here presents very different, looks very, very different. In fact, looking at M82 here, you'd almost be confused if you've ever seen a galaxy like M81 or the Milky Way. Drawings of it, this doesn't not look familiar at all, unless you've seen the Milky Way in our night sky. Because we're seeing M82 the same way we see our Milky Way. We're seeing it edge on. So our Milky Way is a cloudy band across the sky because we're right inside the Milky Way and we're looking out through it. M82 here that we're looking at our screen in front of us, that is 10 million light years away, not very close, but it's also edge on to us. So we're seeing that disk of the galaxy. So from what we can tell, it is probably another spiral galaxy. There's some hints of spiral structure we've been able to pick out. But we've also been able to see this evidence of star formation. These hazy things sort of sticking out from the sides here, these are massive plumes of hydrogen gas that are being expelled outwards. They're being expelled out from around the core, the central region of M82, most likely related to intense star formation going on. And all the stars, they're born, and some of them as they die and explode, pushing out gas and dust, giving us this beautiful view of hydrogen glowing red here in the H alpha part of the spectrum. And making, again, a magnificent sight. You won't see those hydrogen plumes, but again, with a small telescope, for maybe 6 or 8 inches across, you can pick out a faint band of light there in the sky, that galaxy edge on, or the faint hazy outline of M81 over there. So these dark skies, if you can get out under them, convince all our neighbors to turn off their lights, and turn off our own as well. If you happen to not know that they're on, like myself, we can start to see these things. Of course, there are many more objects we can see in our dark skies. Globular clusters, M3 is sort of coming off the handle here. This is a fairly bright globular cluster, a collection of hundreds of billions of stars in orbit around our Milky Way galaxy. So this is much closer than M81 or M82. Here I can see, in fact, that it's only about 33,000 light years away. So it's like right in our backyard. We have hundreds of globular clusters orbiting around the Milky Way, so they're always a delight to look for. We can also see here as we've come along, we're looking now to the east, and we have actually down here, we have, actually, you know what? Let me go back to the Big Dipper for 1 second. We'll leave just we'll leave Ursa Major up. If you go a little bit later in the night, this is something we talk about in the spring, but I'm just gonna pretend we're looking here at midnight. Why not, right? It'll be a little chilly, but you'll survive. It's Minnesotans. We're Minnesotans. We can do it. If you take the handle of the Big Dipper and you follow this arc downwards, it brings you to this very bright star here called Arcturus. Arcturus is part of the constellation. It's the brightest star in the constellation of Bootes, the farmer or the herdsman. In some stories, he's the person who invented the plow. And so he's actually pushing the plow, or the Big Dipper, in and through the night sky. To me, though, he always looks more like a giant ice cream cone. So if we take the ice cream cone here, this triangle shape, and we follow it down, we imagine a line coming straight down from it. We find the star Spica, this blue-white giant star. Spica is part of the constellation of Virgo, or the Maiden. And Virgo here also sometimes associated with the goddess of the harvest in Greek mythology, whose name I'm forgetting right now. Virgo here, depending on how it's drawn, the image might be drawn. We see a head up here, but sometimes these arms up here, or these lines up here, are depicted as arms stretched out over her head. And cradled within those arms here, we actually have a whole group of galaxies known as the Virgo cluster of galaxies. The Virgo cluster contains hundreds, thousands of galaxies that are all bound together by their own gravity. So they're all within a few million light years of each other. This is very similar to how groups of stars like the Pleiades are bound together. But the Pleiades are within our galaxy. These galaxies in the Virgo cluster are completely separate from us. They are tens of millions of light years away. You could spend, and many astronomers have, just studying the Virgo cluster and all the galaxies here. I want to point out just one galaxy. I'm going to quickly search for it. Right there in front of me. The Virgo galaxy, I know it better as M87. M87 is a massive elliptical type galaxy, 1 trillion stars, give or take, in it, and also this bright line coming out from it. If you get a chance to see M87 from here on Earth with a backyard telescope, it'll look like a bright blob there. If you happen to take 7 different radio telescopes, though, and you put them all around the world, and you spend years looking at M87, this is where you could also find a supermassive black hole. That supermassive black hole sitting at the center of M87 is the first black hole that we've ever photographed. This happened just a couple of years ago with work done by the Event Horizon telescope, the telescope to look at the event horizon of a black hole. So as we work our way into the spring, the galaxy that hosts this black hole is becoming visible to us, and it is so cool to see. We may not be able to see that black hole, but just getting a look at this light here from tens of millions of light years away is an incredible experience, personally speaking. All right, I'm going to point out just a few more things. I know we're reaching the end of our time there. I'm going to come, in fact, just a little bit later into the month, into the end of February, and a little bit later into the morning. So something for you early risers here. I'm going to turn off our deep sky objects. We're going to go forward here, and we're going to look low in the eastern sky. In fact, I might have to go just a little bit further here. Not quite 7 o'clock, but around 6:30 or so in the early morning. Jupiter and Saturn will make a new appearance here at the end of the month. They'll just start to become visible. And on the 24th in particular, the planet Mercury will be at its highest point in the sky during February and the easiest to see. Still pretty close to the horizon, still very faint, but a great sight to look for. All right. I think I heard in the background, I think I heard a noise. Sarah, is that you?
Can I share my screen?
Go for it. All right, folks. I wasn't totally sure to mention this before. I wasn't totally sure what's happening. We had some technical difficulties earlier, but my colleague Sarah, who I mentioned before during our Constellation Hunter program, has gotten a view of the moon for us to look at. Awesome. Thank you so much, Sarah. I'm glad this worked out. Do you mind briefly just giving us a quick idea of what we're looking at?
Okay, so we're outside looking kind of northeast-ish, and the moon is just rising today. So we can see here that it's the waxing gibbous moon. So we can see a little bit more than half of it. And what's really cool is down kind of over to the left side of the image, we see the big, huge crater Tycho. It's nice and bright, and then it has all these nice ejecta lines spraying out from it. And so that's one of the really big craters that you would be able to see with a pair of binoculars probably from your own backyard. Now, you might notice, hey, the sun's still up. Why does it look like the moon is at night? Well, right now we have our black and white camera attached here, so we're not getting that blue coloration of the sky, but we are being able to see the whites and the dark grays of the different moon rocks here. So those really dark areas are the Maria, made of a lot of basalt, and those whiter regions, those are the mountains, the highlands, made up of a lot of anorthosite. And so it's a lot of really cool features. Seeing the moon out in the blue sky is actually one of my favorite sights. It's kind of tied for me if I see it here in the daytime sky, if I go look at it during the first quarter moon.
Yeah, the moon is always beautiful to look at. And we had a clear night last night as well. I saw it and I was just sort of shocked for a second that it was there. I think mainly because it was a clear sky. But here in the early, or not even sunset yet, just right before sunset, it comes into view. And as we go later in the night, it will get easier and easier to see. It'll stand out in contrast to the sky behind it. And you'll get a better view of those craters. Binoculars will be a great way to look at the moon. They're one of my personal favorite ways to look at the moon. And we are approaching the full moon. So we'll have the full moon in just a couple days. And during that time, the full moon is beautiful to look at, but just as a heads up, it tends to wash out everything else in the sky. So if you're looking for some of those deep sky objects, even some stars, the moon does make it a little bit more difficult. But luckily, it's on this trajectory around us every 30 days, on this orbit around us. So even when it's full, it'll wane again, and we'll get those dark skies. Amber, I want to pause again and just see any other questions, especially now we've got the moon up here. If you've got moon questions, feel free to ask them.
Yeah, we can maybe give people just a moment. I haven't seen any moon-specific questions, although a couple people are indeed very excited to see it through the telescope view. I'd like to take a moment to thank Sarah for braving the cold that's the observation deck today.
Yes, Sarah is outside in the wind. You probably hear some wind behind her there as she was talking. I think it reached a high of 20 degrees today, I think, from what I was seeing. So, Sarah, thank you so much for agreeing to do this. All right. I think I actually quickly checked. I saw a question there. With someone wondering what time we were looking at earlier on when I was showing that view of the sky. So this program will be recorded and it'll be up on the Facebook page, so you can rewatch it. Keep an eye out for the upper right corner of the screen. Hopefully that's where I was keeping the time and the date. So hopefully you'll be able to read that. We started in the early evening during the beginning of the month. We went later in the night during the middle of the month, and we very quickly ended there the very early morning, around 6:30 or so at the very end of the month. That is the month of February. But if you do want to get a better look at those things as well, and if you don't have a chance to go outside, check out the program I was using, which is called Stellarium, Stellarium. I believe the website is stellarium.org. It's a really fantastic program. I'm using it on a computer, but they have it for an app as well for your phone, or tablet, or mobile device. And it is a really fantastic. It's one of my absolute favorite ways to to look at the night sky. It's a really simple and easy to use program. Just going up and getting started, but then you can do so much more with it as well.
So Tad, we have had a couple of questions that have rolled in. The first one is from Jen, and she's wondering if this image of the moon is at an angle. She said, I can see the moon out my window and the dark spots look different. They're in a different location.
Great. Oh my God, great observation. I'm so glad you're looking. You're looking right now. That is so cool. I'm staring at a blank wall in front of me. Unfortunately, I wish I was looking at the moon. Sarah, do you mind hitting that histogram button up there on the left side if you can hear me? Excellent, thank you. So the view is different here for 4 different reasons. The first reason, to start with, in no particular order, we are looking through a camera. So this camera is going to have its own orientation as well, and it's sitting in a telescope. So depending on how the camera is sitting in the telescope, that's going to change the view, and then the telescope's at an angle as well. All these things are going to contribute to making this look turned on its side. So the way you are seeing it right now with your own eyes, if you're looking out the window, if you're looking at it right now, that is the correct view of seeing the moon. It's something, the image flip orientation, how it looks staring through a camera and through a telescope, is something that astronomers tend to get really used to, just because you never know how it's going to look. So you just sort of take it as it is and work from there once you can start to see it. But south is, in this image, south is on the left. North is on the sort of right, and east, or what would be west, would be down on the bottom-ish, with Mare Crisium there, the nice round one on the sort of bottom side, and then the whatever side's left on the top view.
So so if you wanted to take this image, like if you were to look outside and rotate it counterclockwise by about 90 degrees, that's what I see outside with my eye compared to what I'm seeing through the telescope.
So rotate that, yeah. So if you tilt your head to if you tilt your head to the right, just like touching my ear to my shoulder, it looks, I think, just like it would outside. I'm not going to do that for very long though. That's I clearly need to stretch more. I need to catch up on my pandemic yoga.
We also had a question from Jean. Jean is wondering if you can explain what causes the visible and bright ring that you sometimes see around the moon.
Yeah, is it, yeah, I think, there might be 2 options there. If we're seeing one now, if there was a view briefly through the camera, I'm going to guess that it's because there might have been clouds moving over. So we were seeing some light reflected through the clouds, sunlight bouncing off the moon, or just sunlight from the sun, that reflecting around in our Earth sky. So that could be one option. That's probably also the reason if you're seeing it at night. I guess that if you're looking at night and you're seeing some bright rings around the moon, bright rings, that's coming from ice, clouds, but in particular ice in the upper atmosphere. So this ice in the atmosphere of ice in the atmosphere of the Earth is going to refract and bend and scatter that moonlight, which is reflected sunlight. And that will cause, because the moon is that circular shape, that light's going to come outwards, and it's going to hit it at an angle, and it's going to form that ring. It's all going to hit sort of the same angle there, and it's going to form that ring around the moon. That is known, I believe I got the name right. Sarah might help me out. I know there are sundogs, but I believe these are called moon dogs. Sarah, do you know, have I got that right? Give a moment to...
I've seen a lot of sundogs, and we'd see those around the setting sun as the light goes through some ice crystals in the atmosphere. I don't know that I've ever seen a moon dog personally,
Okay.
but I'm not quite sure.
Okay, so this is gonna be something to look at. I'm gonna guess it's probably easier to see around the full moon. So right now, in the next few days, and then as it starts waning. And a quick little bit of research does say I got moon dogs right. It's always nice on a new question. And yeah, we've got that ice in the atmosphere. So either in both cases, this would be light going through our atmosphere. If you're seeing it yourself with your own eyes, I'm guessing that'd be probably something like a moon dog. Here in the case of the image, if you're seeing it through this view, I'd probably guess that there might be just a little overexposure from the camera, causing that sort of glow around it.
We have one final question, and it's not necessarily related to the moon, but I know it happens to be a favorite of both you and Sarah. And Brian's wondering if you can explain the difference between a galaxy and a globular cluster.
I can definitely do that. And I think I saw a brief question, Amber. I'm going to ask you if you can throw that URL in the Facebook thing there, because I realized me spelling the URL, good catch on that. Me spelling it is probably not the most helpful. Okay, the difference between a globular cluster and a galaxy, that was it, right? Okay. Well,
yes.
let's take a look. Okay, so I've come back to Stellarium. Let's look at the globulars and the galaxies that we were looking at before. All right, so we're here. Time and date is here in the upper right of the screen. We had that question earlier. And we are going to look for, you know what, I'm going to make it a little bit easier. I'm going to come back earlier in the evening. I know I'm looking, there we go. There's the Big Dipper. That's what I was searching for. It's really easy when you can just change time to get it right where you want. Looking at this, let's see what we've got here. So we've got some galaxies here marked out in red circles, and we've got some globulars marked out by this sort of yellow cross patch here. Can zoom a bit so we can see them a little more clearly. And the big answer to the difference between these globulars and these galaxies is more or less what is around them. So both globulars and galaxies are collections of hundreds of thousands, well, in the case of globulars, hundreds of thousands of stars. In the case of galaxies, going up to billions or trillions of stars. Globulars, though, orbit around galaxies. Galaxies are sort of their own objects by themselves. So if we see a galaxy, we might see globulars going around it, but the galaxy with that main central thing there. Globulars will also, they won't have any star formation happening. So the stars that we see, for example, I'm going to try to, where is M53 there? There's M53. If we look at M53 here, this particular globular cluster, we see a bunch of stars. There's a bright outer ring here. It's probably undergone something known as core collapse. But we don't see new stars being born. We just see a lot of very old stars. Globulars, they tend to be, in fact, the oldest stars that we can see tend to be in globular clusters, usually going back 12 or even 13 billion years. So some of the first stars to form in our universe. But because of that, because they're so old, all the gas and dust to make stars, all that's been used up. So we don't see any. We don't see any new stars being born. On the other hand, if we go back to my favorite galaxy, way over here above the Big Dipper, above Ursa Major, if we go back to Cigar Galaxy or M82 and M81, this is where we find in these galaxies, where we find these patches of light. I'll focus on M81 here, Bode's galaxy, where we see these patches of light in red that mark out star-forming regions, nebulae where stars are being born. When stars are being born, these regions are rich in hydrogen gas, and that hydrogen glows this very distinctive reddish, pinkish color. So again, going back to the question, globular clusters will orbit around galaxies, so they'll be part of this other object in a sense. And then especially they won't have any stars forming in them. So they'll just be, globulars will just be the stars there with not a lot of other activity. Galaxies, on the other hand, will have a lot more stars as well, but also tend to have this star formation going on. Not always. Galaxies don't need to have star formation going on. We know there are galaxies out there that generally don't have a lot at all. We also know that there are some galaxies that are very small. We know that there are galaxies like the Large and Small Magellanic Clouds. These are classified as galaxies. They're classified as dwarf galaxies. And these are actually going around the Milky Way as well. Although, excuse me, those do have, the Magellanic Clouds do have star formation happening in them. But we do know there are smaller galaxies that can orbit around other larger galaxies. So at the end of the day, some of this tends to be what name fits it best, just on what we know as we study something. And I wouldn't be surprised to learn if there were globular clusters out there that were originally called galaxies, and then got changed to globular clusters as we learn more, or vice versa, galaxies that were called globulars, and then we changed them into galaxies as, again, we found out more about them. All right, a very long answer. I hope I answered that somewhere along the way. Amber, I can see you laughing there on the other screen.
We didn't get any other responses, so I'm guessing that you answered their question.
Okay, excellent. Sarah, do you think we could get one final view of the moon? Could we end? Do you know if we could end on that? All right. Usually I like to end on a bunch of constellations, but I think it'll be a better view today if we take a look here at just the last look at our beautiful moon. The Mare that we can see here standing out against those brighter highlands, craters like Tycho on the left side there. One of our viewers out there is already watching it, but I hope if you get a chance, you do get a chance to go outside and take a look at our moon. Hey, it's clear out right now if you can. Head outside right now or over the next few days, weeks, months, years. And regardless of what you're seeing, though, I hope that you're all staying warm and staying safe as we continue through these times. And thank you so much for joining us today. Have a great rest of your day, great evening, and I hope you all have a great February and take a look at the night sky. Bye.